Welcome everyone to the Bolt-A-Thon. I'm excited to introduce to you Christian Decker from Blockstream. But before we get into the presentation, I have a quick sponsor shout out. And this is our first ever gold sponsor ever for the Bolt-A-Thon. So we're really excited about it. And it is from the Litecoin Foundation. I think they are right there. Boom. Okay. And they are a nonprofit dedicated to advancing and promoting blockchain technology, primarily through the Litecoin cryptocurrency. They are our first gold sponsor, so huge shout out to them. And this is one of their ways of giving back to Bitcoin and the Lightning community. So we really appreciate them for that. All right, well, Christian, thank you for your time, and you can totally take it away now.
Cool. My name is Christian. I work for Blockstream. Before that, I did my PhD on this stuff. So I've spent quite a bit of time on this. So today I'm going to talk about how you can use C-Lightning, which is the Lightning daemon and client that we at Blockstream are building to do some really advanced and really cool stuff regarding protocol development, for example. So before I begin, let me just quickly say, if there are any questions, please write them down, and Andrew, you will jump in and interrupt me. I do like lively sessions, so please don't hesitate, and just if you have any questions, then we can take them right away. Okay, so basically what we have done with C-Lightning is we are building a very tiny core that implements the Lightning Network protocol, and we try to make it as lightweight as possible. It's written in C. It should be deployable wherever C runs, but it also means that we are not implementing all of the cool bells and whistles, but we are trying to expose as much of the base functionality as possible to our users, so that you can really make the Lightning daemon your own and adapt it to be what you need it to be. And that involves a part of that involves creating plugins or creating clients. And there's a subtle difference between the two, but so far we've always talked about basically creating some cool tool that makes use of the Lightning Network. Well, today I want to talk to you about how we can use C-Lightning and the interfaces that we expose to basically advance the technology itself, and how you can use that, how you can build some prototypes for the protocol itself and help us basically figure out what the protocol should look like. Why are we doing this? We as protocol developers, we are a relatively small team, and we don't have the ability to create all of the cool stuff that is out there. So by giving you the tools to develop this and basically help us figure out this stuff, we are hoping to basically allow you to be to participate in this process. Okay, so unlike previous talks that we gave, these are some really detailed tools that we are trying to expose, and I'll quickly go through them about how what tools they are and how you could make use of them. So these are a couple of changes that I have been implementing and tinkering with over the last few months. And the first one that I'd like to present to you is the send custom message and the custom message hook. So if you're familiar with the Lightning Network protocol, then you know that between two peers in the Lightning Network, we have an encrypted transport based on the NoiseXK protocol that allows you to send messages back and forth. And this is sort of the lowest layer of the protocol stack. And this so far has been fully managed by C-Lightning itself. And there was simply no possibility for you to inject a custom message that you might need in order to implement some really interesting functionality. And we had some proposals lately that were building on top of, hey, it would be cool to have an additional message that has such and such feature. So with the send custom message RPC method, we are giving you the ability to basically having these two nodes connected, basically to inject a message on one side and have it send over the encrypted transport and pop up on the other side. And the send custom message RPC call and the custom message plugin hook are basically the ways that allow you to send and receive these. So the send custom message is basically just an RPC method where you can say, okay, please go to, this is the node ID of the peer I want you to send this message to, and here is a hex encoded message that you ought to send. And the custom message plugin hook is basically once you receive a custom message on the receiving end, then the C Lightning will look at this message and will decide, hey, do I know how to handle this? If yes, I will handle this internally. Otherwise, it will go and look, do I have a plugin that has registered for handling of these custom messages? And so with these, if you create a plugin that registers such a hook, you can actually then receive this message and elaborate on it however you want.
One question is there a size limit to the custom message?
There is a size limit to the custom messages, and that limit is dictated by the transport layer. Basically, all of our messages are prefixed by a 2-byte length. And so the messages themselves have a maximum length of 65K. And that's shared among all of the messages we send in the Lightning Network. The 2-byte prefix was an early choice. And we had a couple of cases where this wasn't sufficient, but for most cases, 65K is more than enough to do whatever we want.
And another question is, does this help with WhatsApp? And maybe the question is like, is it interoperable with WhatsApp? Or yeah, I'm not sure.
So this is not directly related to WhatsApp or any like chat protocols. We have actually the next slide will talk about WhatsApp and how we can implement it. Actually, the whole example I will be giving is implementing a chat. So
perfect.
So this is between peers that are directly connected to each other. So if I have a connection open with Andrew, for example, I can send messages directly between my node and Andrew's node. Whereas the chat application requires us to route messages over other peers as well. In which case we will package all of this in an onion, and that's on the next slide. So with send custom message and custom message being able to inject and receive messages, we now have the ability to do some really interesting stuff. Like, for example, we can implement some more advanced gossip messages. We can implement a lot of prototypes that we maybe want to propose to the specification effort. But before we do that, we want to actually see how it performs in real life. So we can actually go out and implement these before there is any need to come back to the table and sort of share the results with our fellow specification authors. There's the idea of maybe sharing block headers over the overlay network. So basically, if you have a light client, you can basically ping him and say, hey, by the way, I just received a block header. You might want to check whether there is a block that you'd like to retrieve. Or something that René Pickard has been talking about, sharing some information about, inside of the network, basically gossiping a bit more about capacities of your channels in order to find optimal rebalancings among your peers, and basically doing them for free if you had a negotiation ahead of time, so that you can say, okay, we all want to do this rebalancing, let's make it for free, basically. And this is, there are many more examples of this. These are just the ones that I came up with while implementing it, and I'm sure it's not an exhaustive list, and there will be many more things that we can do. So this is basically what allows you to have peer-to-peer communication. And in the next proposal, which is actually implemented and already merged, that's the create onion and send onion RPC methods. So if you remember, the Lightning Network works by passing messages along a route. And this route is computed by the sender when he wants to initiate a payment. And the way that we tell intermediate hops where to go next is basically by creating an onion. Each participant unwraps the layer of the onion, finds information about where it needs to forward the stuff and a bunch of other parameters, and then rewraps the onion and forwards it to the next participant, which then again unwraps and forwards until we get to the final destination. And the final destination unwraps once more and says, oh, I don't have anywhere to forward this, so this is a payment destined for me. Can I actually settle it? And what the takeaway message here is that basically what you can do is, for every node along the path of your payment, you can actually have a small payload that you can deliver to that one, and the node is the only one that will be able to read that payload. So it's a secure mechanism for us to communicate some information to peers. And since that is a rather flexible thing, we have generalized this and made it available using the create onion and the send onion mechanism. Create onion, basically you give it a list of peers that you'd like to contact one after another, and then for each of them you give them a small piece of information of what they should receive. In most cases it will be the routing information, but for example, in the example of the chat application, the final destination, the recipient of the message, will actually unwrap this onion once and see, there's a message in there, I should probably just store that somewhere, and you can actually then notify a reader or something like that. If you have a web interface, you basically pop up a notification, hey, I just got a message. And examples of this, I have a couple of more of them because, well, this is the stuff that I have been working on the most lately. So we do have atomic cross-chain swaps. Basically, what you do is the payload for the point where you swap from one currency to the next one. You tell it, hey, by the way, I'd like to switch from Bitcoin to Litecoin, or from Litecoin to Bitcoin, or from liquid BTC to BTC. And this information you can bundle up in the onion itself, so you don't actually need to go on a website of whoever is doing the exchange, but you can confer all of that information inside of the onion itself. And so your payment and the exchange of the information becomes atomic. Of course, there's the chat message application that Joost has been building with WhatsApp, and we'll see in a couple of minutes how we can actually go ahead and implement this ourselves. And there is a couple of other proposals that I'm currently working on, namely the rendezvous routing prototypes, which is a mechanism where you can have the recipient of the payment remain anonymous, and the sender of the payment remain anonymous. This is different from what we have today, in that today we basically have the ID of the final recipient in the invoice as the destination. And with rendezvous, we can basically get half an onion from the destination, and we compute our part to this rendezvous point. We combine the two onions, and then we have one onion that goes from me to the destination without either of us knowing who the other guy is. And trampoline payments is a mechanism that should allow us eventually to have much more lightweight nodes to perform payments without them having to synchronize the gossip. So they don't know as much of the network, so they basically just defer the actual route selection to some node in the network. And thus we can reduce the startup time, and we don't need to carry around all of this information about the structure of the network, but we can do, or we can externalize that. And of course, there's many more. I don't claim to have an exhaustive list. And I'm pretty sure you guys can come up with something that is really cool as well. And the final part is a bit more about signaling. So what we've done with the custom message structure, you can have peer-to-peer communication. With the onion construction, we can have end-to-end communication that goes across multiple hops. And with the feature bits, which is still in development, we will have a way for us to signal, hey, I do support X. I am a WhatsApp client. I support atomic swaps. I support trampoline payments. And this is basically a way for the plugins to signalize, hey, I have these advanced features. I'd like people to be able to find me when they are looking for somebody that supports these features. And I don't have too much on this right now because it's still a very much experimental feature that I'm currently building out. But eventually it will be able to basically tell, hey, these are features I'd like to signal, and they will be added, they will be ORed into the features that are native to C Lightning. And then when you announce your node, when you send a node announcement into the network, they will carry all of these features. And by looking at the gossip messages, you will be able to say, hey, this node I've never talked to before, but he supports atomic swaps. Or this node I have never met before, he supports trampoline payments. And I can actually then go ahead and contact them directly. Okay, so these are the three big chunks that are implemented, that are coming, or that are currently under review. So these are the three basic extension points that I'd like people to use, and that should give people the ability to build out whatever nice protocol improvement they have.
So I actually had a question on that. Like, I feel like protocol development is hard because you have to have like a really good understanding of how the dynamics work and how tweaking something will affect the entire network and all that stuff, right?
Yeah.
And so I guess, and I think and keeping it part of like the repo allows people to like review it and make sure everyone's like has a good eye on it. Do you see any problems with there being like a plugin structure for protocols with C Lightning?
I think, well, I think that ship has sailed pretty much. People will want to experiment with this stuff. People will want to come up with their own features, and will basically hack on whatever is there until it gets them working. I mean, Joost's WhatsApp is a fork of LND, which he will now have to maintain. By giving people these very well-defined interfaces in the form of RPC calls and plugin hooks and so on and so forth, we want to make it easier for users to implement this this kind of add-on to the protocol itself, but also make it maintainable in that you don't have to maintain a full clone of C Lightning, and whenever we break your changes, you have to fix them again just to get your feature back working. These are interfaces that we have committed to maintaining, and these are interfaces that you can count on being there in the future. In fact, these interfaces are used by us internally as well. Little known fact is that, for example, that the pay command, which you can, which is the one-shot command where you can give a Bolt-11 invoice is actually itself a plugin. And it makes use of some lower down functionality to actually implement all of the logic itself. So we ourselves rely quite heavily on plugins being plugins working and this interface being stable. And this is a promise from us to users that want to build on it. We will not break your stuff when we release a new C Lightning version.
So we have to trust you. No, I'm just kidding.
Oh yeah, open source and trust. That's a biggie.
Yeah, so this is actually really interesting because it almost sounds like there could be like several layers within Lightning of like what types of plugins are communicating with each other. Would you say that's
absolutely
accurate?
Yeah, so basically one one of the prior questions was is this compatible with WhatsApp, and how can we find people that are using WhatsApp? I tried to make my own chat plugin compatible with WhatsApp, and so there might be a WhatsApp feature bit which would allow you to basically say, hey, I'm using WhatsApp and Andrew is using WhatsApp. I have him in my friends list, and this is his ID. And the feature bits is basically how we could find out. If there were a different chat application, if there were a different, let's say 10 cent for Lightning, and the protocols were incompatible, we could use different feature bits. And so there could be various versions of chats that might be incompatible, but that they don't interfere with each other. So you're basically free to pick some bits that represent you, and then you can build your own extensions on top of the protocol itself. There is no gatekeeping for us from our side. You're totally free to implement whatever you want. If it is to become part of the specification, then we might go over it and see how whether it fits with the overall philosophy of the Lightning Network protocol. Otherwise, you're free to do whatever you want.
So this is
Keep in mind, though, that collisions between these might have nasty side effects. So just randomly select a number and try not to all take the same numbers just because they look cool. Dibs on that beef, by the way.
Ooh. Okay, so like this might even, I'm even thinking about like enterprise level like plugins, or let's say for Lightning games, like let's say there's a specific plugin to do Lightning games, and you do it with like all users have their own Lightning node to play the Lightning game, and you share a vast amount of information between these nodes, but then it doesn't affect like the base layer of the Lightning network, right?
Exactly, yeah. So so the use of the onion to communicate information means that you can actually communicate over nodes that might not themselves support your fancy extension, but you still have the ability to communicate through them to get to nodes that do. So all of this is nicely compartmentalized, and there should be no interference.
Okay, two more questions. Is dropping the chat message off at a hop more private than routing the message to the final hop? This goes back to the messaging stuff that we were talking about before.
Sorry, I didn't get the first part.
Is dropping the chat message off at a hop more private than routing the message to the final hop?
Oh, I see. That's an interesting one. So in a certain way, it is more private because some of the parameters in your in the payment that they are attached to change slightly. For example, the check lock time verify. No, the HTLC timeout is depends on the length of the path, and so if your real recipient is not the final hop, then you have what's called a shadow route. Then again, C Lightning does compute shadow routes automatically, so you don't actually have to do that manually, because C Lightning will fuzz the amounts and overestimate the amounts in such a way to hide your intended recipient a bit more. So that's something that we already do internally, but you can, of course, do it manually as well.
Another question is, are there any discussions with other Lightning implementations to implement these custom messages in a compatible manner?
So I mean the function, the way that we expose this functionality is pretty unique to us. We chose to make these very low-level tools available to users so that they can build on top of this. As far as I know, the other implementations do not expose this kind of low-level information at all, though some of it is getting re-implemented, and more and more of this is being implemented. If I remember correctly, L&D has just released a one-shot pay, which is our old send pay command. So this allows they started off with more higher level APIs and are now sort of tracking back, and we started with the sort of the lowest level API out of the gate and build abstractions on top of it. I'm not sure if there are any plans for other implementations to expose this kind of interface, but if not, you can still modify the channel, the implementation itself, and get sort of the same access, I guess. Okay, so if there are no more questions, we can get started to build a chat. So like I mentioned before, this is sort of the pet project that I chose because it's cool and it seems to be people really like it. Let me show you how easy it is to implement something that is relatively complex, like routing a chat message through an overlay network such as Lightning with some really, really simple tools. And I will build this in Python because Python is sort of a is pseudocode written in an interpretable form. However, there are client libraries for Java, there are ones for C, and there's for Rust and Go. I just found Python to be the most accessible, and it's also the RPC implementation that I built, so I'm mostly familiar with that one. Okay, so just as a quick overview, we will have two RPC methods. On the left-hand side, we have the send message. This is an RPC method that is implemented by the plugin. So as soon as CLightning receives a call to send message, it will figure out that, hey, this plugin said it supports the send message RPC method, and it will basically take the arguments and pass them down to the plugin. The plugin will then do some magic, and eventually the message will end up in the chat plugin on the recipient, from where it can then be retrieved using the receive message RPC call, again implemented by the chat plugin itself. Diving a bit deeper, the sender will have to do five steps to actually get to send the message. The first one is it will have to compute a route from itself over these three intermediate hops, or however many there are at the moment, and how to get to the recipient node. It will then have to compute for each hop, it will have to compute, hey, what do I need to tell this guy in order to forward the payment, or in the case of the last one, how do I tell this guy about the message that I want to deliver? It will then have to encode the payload in the onion. Again, the onion is this big packet. It's 1,300 bytes, so it's not really tiny. And it contains the information of the payloads for each individual hop, as well as the information to decode the message. And then the sender will have to take this onion and initiate a payment using it, and that will then deliver this message. And optionally, it can wait for this to happen. The recipient will receive the payment in the form of an incoming HTLC. It will decode the onion and it will extract the message itself from the payload. And finally, it will have the ability or not to claim the payment. This last part is only possible if the payment corresponds to an invoice that the recipient created. Okay, so let's jump into code. This is what a classical PyLN plugin looks like. It basically just says, hey, I am interpretable using the Python 3 code. We do import some stuff. We create a plugin, and then we wire stuff together. And this is basically all we need to do. We have a method to send a message. We have a method to receive a message. We have a method to accept and to decide on what to do with an HTLC we got, and we have some initialization. And finally, we have the run loop, which allows you to initiate the plugin. So if you've ever built anything using the Flask, which is a very nice and very popular framework for web development in Python, this should look very familiar. Basically, what you do is you create a plugin, and then you register stuff that your plugin should do whenever something in C Lightning happens. Let's get to the initialization. First of all, we just need to have a place where we store messages that we receive. In this case, we will just create a messages array, a list of messages that we initialize to the empty list. And that's basically all there is to see in the initialization. Then on the receive message RPC call will be used to retrieve messages that we've received in the past and expose them to the user. So if we have a message, then we'll return that message. Well, if we have at least one message, we'll return the first message. And if we don't have any message, then we return nothing. So far, nothing special, nothing really Lightning related at all. So that's the next step. The next step is basically when we receive an HTLC, what do we want to do with it? And in this case, we get a type length value payload, the so-called TLV payload. More on that on the next slide. But we basically just take this TLV payload and we decode it, and then we take. You can think of the TLV payload like a hash map from integer to binary objects, or like a dictionary in Python, or like a map in Go. It basically just has key value pairs in them. And so we take this 34, 34, 9, 3, 3, 4, which incidentally is the number that Joost chose for his WhatsApp demo. And so I try to be compatible with that. And so we just take this message and put it into the array of messages. And then we have this result, which basically tells C Lightning, hey, I'm done handling this HTLC. I can't accept it. I can't reject it. You decide on what to do with it next. And indeed, if this payment corresponds to an invoice, by telling C Lightning to continue, C Lightning will then take this and be able to accept the payment as well. So I mentioned that we have TLV payloads. TLV basically is just a mechanism for us to encode messages. It really is just a set of type, length, and value pairs, and these the multiple of these TLV key value pairs form a TLV stream, and the payload in the onion itself is formatted as a TLV payload. If you want to have more on these, more details on this, I suggest looking at Bolt-A-Thon, which explains all of the message details in a very detailed manner. Okay, so this is all the easy part. Let's get to the really hard part, which is the sending part. Sending is hard because, well, it's basically a Lightning payment, and Lightning payments are all driven by the sender. So it's up to the sender to compute a route, to compute the payloads, actually stash the message that you'd like to have sent in the last payload. Then we create an onion, and then we initiate the payment. And I'll go through this step by step. So computing a route is relatively easy. It basically is just an RPC call from us to get to the destination. And in this case, we want C-Lightning to compute a route from us to the destination for 1,000 millisatoshis. So that's 1 Satoshi, and a risk factor of 10. Don't ask me about the risk factor. I never grok that one. I just put in 10 always. And then we just extract the route. The route itself is just a list of objects, and each of these objects contains basically the node ID that we want to reach, how we reach it by saying, okay, this is the channel you ought to take, and the amounts that we want to forward. So if I were to send a payment through Andrew to my colleague Rusty, and I want 1,000 millisatoshis to reach Rusty, then I would probably send 1,010 millisatoshis to Andrew and give Andrew the instructions, hey, I know you're a neighbor of Rusty, please forward 1,000 to Rusty. And the difference of 10 you can keep as a routing fee. Okay. Compute payloads is the next slide. That's a bit more complicated.
There's a question.
Yeah.
When defining the route, can you also set an arbitrary number of hops?
Currently not, but you can chain them quite easily. So if I wanted to have a route that goes through a particular node, I would probably first compute a route from that node to my destination, take the parameters I got there, and then compute from me to this first node such that enough funds arrive at this intermediate node that I want to jump through. So you can actually chain them quite easily and create arbitrarily long and complicated routes in the network. You can even compute them externally, but C-Lightning is rather efficient in how it computes these paths, taking into consideration limitations of the network itself. But yeah, you can combine these get route calls quite easily, and there's a couple of plugins where we do this. For example, for rebalancings, we want to have a circular route. Now, if I were to say, hey, I want to reach Christian, there's very little that actually needs to be done because I am the destination, so to speak. But if I say I want to reach Christian through Andrew, then we actually get this circular route quite easily. So yeah, you can do some really, really interesting tricks by setting some waypoints in the route itself. Very good question. Okay, so we'll see on the next slide how to compute payloads. There's a little trick in there. The important part here is that the last payload will be replaced. So we don't tell the recipient in this case, we don't tell this recipient how to forward the payment because there's no need, he's the recipient. But we basically take the message that we ought to deliver and put it inside of the payload. And then take this last payload, which is indicated by this -1, and we just replace that with this really, really simple payload here. Next, we bundle all of these payloads up in an onion itself. That again uses the create onion RPC call. Important here is that the payment hash will be used, is the same one as we had in an invoice, for example. In this case, we just create a random one with all A's. So by doing this, we know that the destination will not be able to claim this payment, but the payment will get rejected. It's not corresponding to an invoice, but we still deliver the message, which is the important part for us. And then we initiate the payment itself. And then we just say, okay, this has been delivered. Now, all that's left to do is basically see how do we compute the payloads and how do we deliver the message. And computing the payloads is the really hard part. The difficulty lies in the fact that route basically tells me, hey, I want to reach this node. So the entries in the array of the route are not tell this node how to get to the next one, but are, hey, I want to get to this node, and this is how I get there. So there's a mismatch between the two. And what we do then is basically we have to take the route from the second element, so not how we get from us to the first node, but how the second node gets to the third one, and we have to tell that node how to get to what parameters to use. So we just shift these parameters by one, and here we can also see what the payloads are. So at each hop, we tell the nodes, hey, this is how much you should forward. This is how much time, what delay you should use when forwarding it. This is basically a security parameter that allows you to undo a path safely without incurring an erase. And the short channel ID is basically, hey, this is how you get from you to the next one. And this is basically all there is. The last hop is a bit special. If you look at the specification, we had this choice of not putting anything in there because, well, it already had all the parameters. It is a final hop, so it knows how to settle this. But we decided to put a copy in there basically to say, hey, you're supposed to get 1,000 millisatoshis. Did you actually get 1,000 millisatoshis? In this case, I just copied the last payload. That is because that's how it should normally work. But if you remember, we are about to replace the payload in the previous slide. We are replacing this last payload with our custom payload, which contains the message. I will create some helpers for this kind of operation, so you can basically take a route and say, hey, I want this route, and give me a representation as an onion. So you should not have to worry about this too much, but just to show you that there are a couple of details that might be more involved. Yeah, so we will replace the last hop anyway, so this is just a demonstration. And finally, to deliver the message, we just take the onion and we send it forwards. So by doing this, we say, hey, here's a routing onion, how to get from me to the destination. Please try to perform this payment. And since this payment does not match an invoice, we will get an error back, but this error is a bit special, because depending on what it is, namely if it's a 16399, which is, hey, I didn't find an invoice matching this payment, then we know, hey, if we actually got to the destination and we actually delivered this message correctly. If it's not this error code, we might need to retry. So there is a bit more complexity around this, correct error handling, and retrying this multiple times might require you to do a loop around these operations, but in the optimal case, it works just like this. Yes.
Yeah. So Is it easy to share small methods like this, like compute payloads, as plugins or snippets in the C Lightning community?
Absolutely. I mean, we do have the Pylon library, which I'm maintaining. That implements basically the plugin infrastructure, so you don't have to read JSON messages and transform them and make them into function calls. And I'm planning to put these helpers into that library as well. That being said, we also have a repository on GitHub. That is github.com/lightningd/plugins. And there we have a collection of plugins and utilities that people might be interested in. There we can actually also have reuse of code. So we try to have this repository of community-provided plugins, and if there is something useful that you'd like to take from another plugin and reuse for yourself, then by all means, that's why this repository is public. Yeah, cool. So speaking of, I have one more. And just to show you how easily you can actually do this, I have the entire code on a single slide. So if we were to remove all of these comments, we would be down to 65 lines of code, 65 lines of very airy code, so to speak. We could make this a lot more denser and fit it on a couple of lines. But this is just to show you that even these cool, very advanced features can be done quite easily by relying on the correct infrastructure. That being said, the actual plugin that I'm writing, the noise plugin, does have a bit more code because it also stores the messages in a database. And it allows you to retrieve any message that was sent before, and it has correct error handling and this kind of stuff. But by making the interface you have to interact with as easy and understandable as possible, you can get to your business logic as quickly as possible, and you don't have to work around too many quirks, hopefully. So we mentioned before that that we do have a repository for these plugins, but part of this repository is also that we run your plugins against the development version of C Lightning on a regular basis. So with the testing framework we have extracted from C Lightning, you can write very simple tests that will basically exercise the entirety of your plugins and your custom protocols quite easily. And in this case, we basically have a network that we spin up of 3 nodes. It's a line graph, so we have 1, 2, 3, and each of them is connected with a channel. The first one and the last one run the plugin, and we want to have them announced. Once the network is fully synchronized, so we are aware of all the channels in the network, basically the first node, L1, can reach the destination L3. We then go ahead and just send L3 a message, and we wait for it to arrive at L3. So if I have 10 more seconds, I can demonstrate that. So what we have here is basically on the right-hand side, we have the first node. This is L1, this is L2, and this is L3. And if I now go to the third node and see what his ID is, I can then use the first node and tell it to send a message to this node and say, how are you doing? Ooh. And you see on the right-hand side, basically the first node talked to the second node, here is a payment. The second node went to the third node and said, here is a payment. And the third node said, okay, I am the destination. Can I unpack this? And the third node has now has then said, hey, I don't know what you're talking about, but the plugin in the meantime has retrieved the message, has stored the message. So if we now say LCLI3 receive message, we should not, yeah. So I had a couple of new lines there, sorry about that. Let's just do this again. And if I repeat that, we don't have any more messages pending, so we can, so it will just tell me, hey, I don't know what to do with this. There is no more messages here. And by having this test alongside your plugin, we can actually make sure that your plugin doesn't break when we create new versions of C Lightning, and that your plugin remains operational, basically. Okay, so that's all from my side. I would really enjoy if there are any questions. And even better, if you have an idea for a great plugin, just head over to lightning.d/plugins and see if there is already something in that direction, and or to get inspiration how to implement your next big idea. Thank you.
Yeah, thanks a lot, Christian. That was great. I did drop in the GitHub to the plugins, so
yeah,
people get access to that. If anybody has any questions, we have about like 8 more minutes left in the talk, and so I'm sure Christian would love to answer any more questions that other people had. But yeah, it was cool to see that example of you, like the chat example, like with WhatsApp too. I didn't realize that Lightning devs were like forking clients and building customized stuff to create these apps, and so that makes a lot of sense to me.
Yeah, it just, I always find these, I mean, building these applications is really cool, but maintaining them tends to be a burden. It was really my intention to create an interface that remains stable and that people could count on being there when, despite our development and your development moving forward, and not having to basically be an expert in C Lightning and your business logic just to basically keep things working, right?
Yeah, so maybe so I don't have like a developer background. So like, what would be the difference between maintaining a plugin versus maintaining a fork of something?
So the main difference is basically that if you create a fork of a big project that is in motion, and then apply changes to it, then you can keep your changes nice and compartmentalized. But eventually there will be a conflict between changes you did and changes that the upstream developers did. And so if that happens, then you have to invest a lot of time in getting your things working again. And this might be as simple as changing a variable name. So if I change a variable name in C Lightning and you were relying on that being there, then you have to dig in and see, okay, what did Christian do now? How do we get this back working? Oh my God, I have this other deadline. I would like to have my business logic working again, but now I have to dig through somebody else's repository to get this working again. So this is our way of enabling experimentation without creating these tight couplings between us and your business logic.
Cool. A couple of other questions. You showed us an example with Python. What other languages can be used at the moment to write these plugins? And or anything that can communicate with the C Lightning API will do?
Basically, whatever. So the plugin API is rather simple. So if you want to write a plugin, all you need to do is read from standard input and write to standard output. and the messages you read are JSON formatted, JSON RPC requests, and you're writing JSON messages back out. So you could potentially do this in whatever language you want. I've yet to see one for brainfuck or whitespace. But we do have working clients for Rust, for Go, for C, for Bash, I think, and Python. Java. Java is also up there. So whatever you feel comfortable with, there is likely a client plugin, client library. If there is not, it's not that hard to write, and I'd be more than happy to help if help is needed.
Cool. Another question. Is there something to consider regarding denial of service attacks when the middle nodes have to create HTLCs that they cannot claim if it actually sends a message to a destination?
There is a slight issue with that, yes, and there are a couple of proposals out there. The main issue is that you are using resources that are basically not yours. So there is a fairness argument. And one of the proposals that was put forward by Rusty, for example, is the use of upfront payments. So if I want to make use of your resources, I will give you 10 millisatoshis or so. And whether the payment fails or succeeds doesn't change the outcome that you receive 10 millisatoshis, which is different from the fees as they work today, because if you send the payment and that does not succeed, then none of the nodes along the route will get their fees. So probably a combination of upfront payments and success-based payments will be a lot more fair. Yeah, it's currently not that bad, I'd say.
One of the problems I've heard is that the middle node can actually just refuse to route and just collect all the upfront payments, like the first half of it.
Yes.
Is that becomes an attack vector?
So there are a couple of game theoretic problems with the upfront payments, but again, by making a combination of upfront payments and success-based payments, you can still incentivize people to route successfully, despite them already having gotten part of their reward, so to speak.
Okay, another question is, I think Christian mentioned that even making Lightning payments were done using a plugin. Do you have the name of that plugin?
So yes, the plugin that performs payments, as in you give it an invoice and it will try as long as try repeatedly to make that payment. That plugin is called Pay. I can share that later, but it's inside of the Lightning repository. Let me quickly look it up. So there's our internal plugins, and I can increase the font size a bit. So we have the auto clean, the fun channel plugin, and the pay plugin. All of these three plugins are built and shipped alongside with C Lightning, and you are using them even if you don't realize, because they're built in and they have the same access that your plugins will have as well. So if the behavior of the pay plugin isn't what you want, you'd like to be more insistent and try more than 5 minutes, or try multiple payments in parallel or anything like that, you can actually take the pay plugin and modify it completely, or replace it completely with any logic that you'd like, and it will have the same access as our plugins have.
Very cool. And I shared that link in the chat room, so he has access to that. All right.
Back to the less bright background here.
Yeah, dark mode.
Yeah.
All right, are there any other questions?
Oh, we're also exactly on time, so.
Yeah, it's great, perfect. Well, yeah, Christian, thank you so much for your time. I really, this was amazing. I thought it was super insightful. And to all the attendees, We are still selling tickets throughout the day. So if you're interested, make sure to grab a ticket for our next session. We're going to take a lunch break for about an hour, and we're going to come back at 1 p.m. PST.
It's a dinner break for me, but okay. Awesome.
Right.
Thank you so much. It's been a blast. And if there's any more questions, please reach out. I'm always happy to chat Lightning.
Bye.
Cool. See ya. Bye-bye.